All right, y'all. So here we go. 1.7 inverse relations and functions. Okay. So first of all, what an inverse relation is. All right. An inverse relation of a function. Okay, is well, we should say the inverse relation of a function exists if, this is a little bit of a weird statement here, but if when the function contains any a comma b, all right, the inverse contains b comma a. All right, so the inverse relation of a function is when a function contains a comma b. The inverse contains b comma a. So it's note that these are variables, right? So this is for every a, for every b. Okay, there's always the point b comma a for a relation. Okay, now I'm assuming that you've read the little website that I posted that kind of has like the basics of inverses before you get to this. But for an inverse relation, it's a little bit different actually than what the website posted. It does not have to pass the vertical line test. And yeah, so it can have, remember, a relation is different than a function. A function is, a relation that does pass the vertical line test. Okay, but a relation doesn't have those requirements. Okay, so to go ahead and show you kind of 4 different kind of representations of how inverses relate, we're going to go ahead and talk about each 4 of these. Okay, so the graph kind of version, the table, the equation, and then how the domain and range relate to each other. Okay, so for the graph, okay, you're actually going to go ahead and reflect it across the line y equals x. Okay, now this is the line y equals x. Okay, that dashed line is the line y equals x, and if for every for a function or for a relation, if it has an inverse, you're going to literally reflect it across that line. So one way to do this, right, is you could put that. I like to think about it a little bit vertically. You don't necessarily have to, but I'll go ahead and essentially do that for you. Okay, so here it is. We've got these points. Nope, sorry. This point right here is where it starts. Okay, and then it goes. Why can't I do this right now? Here it is. There we go. Okay, and then over 2. Okay, so there's the inverse relation. Okay, there's the inverse relation. So note that this is not a function. Okay, and that's what I was kind of referring to earlier. This is not a function. This does not pass the vertical line test. Okay, and that's why it's called a relation as opposed to a function in this particular case. Now, we will get into inverse functions next, okay, as you can see here. And we can't, we're going to have to kind of force the original relation. We're going to kind of have to force it to where it does pass the vertical line test. So just kind of giving you a heads up of where we're going. That's where we're headed. Okay, for the table, right? So for this particular one, we can go ahead. I'll go ahead and put the values for this. This is negative 2, 5. Just to go ahead and double check. Yeah, negative 2, 5. We got negative 1, 2, 0, 1, 1, 2, and then 2, 5. So how does the function relate? Okay, for the inverse. Okay, now to go ahead and kind of talk about some notation here. Okay, if this was my kind of original, actually I don't want to name it as a function, just because yes, this one's a function, but I don't want to name this a function, so I'm going to take back what I said. But to talk about the inverse relation, okay, if I end up with a negative 2, 5, okay, for an inverse relation, you're actually just going to switch your x and y. So what was the x is now the y, and what was the y is now the x. So we're just going to go ahead and switch them. Okay, so this is the original. okay, and this is the inverse. All right, and we literally switch all of our points. Okay, we just flip-flop them. Okay, so just to make a note, we switch x and y. Okay, an equation. All right, so an example of an equation. All right, so if it was originally, let's say it was 3x, okay, plus or minus 5. Okay, so y equals 3x minus 5. All right, if this was this is a different, separate example than all this. Okay, this is a different equation. If this is my initial, okay, so just to clarify, right, this is not the exact same one. It's just a general equation to see what kind of happens. We've got y equals 3x minus 5. All right, and this is my original. Okay, the inverse is going to be something kind of similar. Okay, and we're going to actually find out how we do that later. And I'm actually going to give you the steps, but just to show you, okay, the new one, okay, would be y plus 5 and then over 3. Okay? Goodness. Just going to be one of those days. Y equals x plus 5 over 3. Okay? And this is my inverse relation. Okay? Now, I'm going to go ahead and give you the steps on this. And like I said, we'll do examples of it later. But in order to find the equation for, like if this was my original equation, in order to find this inverse relation, okay, or another equation for it, there's essentially 2 steps. Now, these steps are actually somewhat complicated, but the actual like big picture steps are very simple. Okay, so it just depends on the equation, what type of equation it is. You know, it could be anything, right? Square root, exponential, logarithmic, you know, whatever it is. In order to convert it, kind of depending on the type of function, will kind of determine whether, kind of how hard it is to convert it to its inverse. But for the most part, like I said, overview, the steps are relatively simple. So you're going to switch x and y. And then you're going to solve for y. Okay, so it's just those 2 steps. All right. If you're very, very good at solving for y, no matter no matter what type of equation you're looking at, then this is it's a very simple process. Okay. For the domain and range, all right, what happens with the domain and range? Well, notice everything is kind of switching, right? And that's exactly what happens with the domain and range. So what was the domain is now the range, and what was the range is now the domain, okay? Okay, so domain, range, go ahead and put f of x here, inverse, okay? It was x. Okay, so essentially, we are going to switch the domain and range. Okay, and it is that simple. Again, what was the domain is now the range. What was the range is now the domain. Okay, so that's kind of what happens with inverses. It's switching your x and y. Okay, as we can see in the table. Okay, for a graph, it's always going to be the reflection across that line, y equals x. And then for the equation, you can kind of see some similarities, but depending on the equation, it's a little different, right? So just to kind of talk about the similarities, we were subtracting 5, now we are adding 5. Okay, we were multiplying by 3, but now we are dividing by 3. And so that's kind of the relationship between, you'll be able to kind of see, like I said, depending on the equation, kind of how they relate as we move forward. Okay, so an inverse function, okay, an inverse function, all right? So in order to know if we have an inverse function, okay, we can say a function has an inverse that is a function. Okay, so that's important. I know that sounds redundant, but a function has an inverse that is a function, right? So remember, the only requirement to be a function is that it passes a vertical line test, that a relation passes a vertical line test. Okay, so a function has an inverse that is a function if it passes both the vertical line test, okay, and the horizontal line test. Okay, now we don't hear about the horizontal line test too often here. Okay, all right, and then notation. Okay, this is separate. Okay, but we'll still go ahead and talk about it here. I'll kind of recap this in a sec, but let's talk about the notation. Okay. All right, so the first part. Okay, a function has an inverse that is a function if it passes both the vertical line test and the horizontal line test. So, a function is a function, or a relation is a function, okay, if it passes the vertical line test. Okay? Now, think about the inverse though. Okay? So let's look at this example up here. This is a good example of this. Okay? This is my original. All right? This is my original. This is the inverse. Okay? So, in order to tell if the inverse will be a function, we've got to see if this passes the horizontal line test, right? Because the inverse of it, right, won't. Okay, so if whether or not this passes the horizontal line test will actually tell us if our inverse is going to be a function. Okay, so this is an example where the inverse is not a function because this does not pass the vertical line test. Okay, it's the same, kind of concept that this one doesn't pass the horizontal line test. Okay, so passing the horizontal line test is actually important to determine if the inverse will actually be a function. All right, so that's kind of what we're getting at in here. All right, the notation, this is just how we write inverses. It's with this it looks like an exponent, but it's not an exponent. We kind of put it in between the f and the parentheses with x, but that -1, it's a 1, just so we know. Okay, that to the -1 power looking thing is just what we call the inverse. So anytime you see this, it's referring to the inverse of that original function. Right? This is just f is a function of x. This is the inverse function of that original. Okay, so let's go ahead and jump in and find some of these inverses. Okay, here we go. So the graph. Okay, first of all, let's just go ahead and knock out the table. Okay, table kind of helps us with finding the inverse. Okay, so let's go ahead and do it. All right, so x, let's just go ahead and start with -3, okay, comma 0. That's that first point right here. Okay, it looks like it also touches this. All right, and then it also touches this. So kind of right off the bat, just for good practice, I can, hopefully we can tell that this is a square root function. Now the reason I know that, okay, is because of this kind of shape right here. Okay, I have this is kind of like my original, like my starting point, and I'm up 1, 1, right? The square root of 1, okay, the square root of 1 gives me 1. The square root of 4 gives me 2. That's so where I'm getting that 4, right, is because it's length of 4. If it didn't have a transformation, it would be shifted over. Okay, so the parent function kind of starts here, and then it goes to this, and then it goes over 4 and up 2. So that's kind of how I see that general shape, because that's kind of like my 0, 0, and it's 1, 1, and then 4, 2. Okay, so if we wanted to go further, right, it could go 9, 3. Okay, wherever that would be. So I guess 3 would be right here. So this is also a point 9, 3 on the original. Okay, but in this particular one, since it has a transformation, it doesn't end up at 9, 3. Okay, so anyways, we've got a -3, comma 0. All right, we've got -2, comma 1, and we've got 1, comma 2, and then we'll go ahead and throw in also that 6, comma 3. Okay, now for the inverse, we're flipping those. Okay, so notice it does have our notation, right? This is the function of f. This is the f inverse. All right, so we're just flipping them. 0, -3. Okay, 1, negative 2. We're just switching their spots, 2, comma 1, and then 3, comma 6. So we can go ahead and graph those in order to get our picture here. Okay, so 0, comma 3, negative 3, sorry, 0, comma negative 3, 1, comma negative 2, okay, 2, comma 1, and then 3, comma 6. Okay, so here it is. All right, and that is my inverse function. Okay, that's my inverse function. Now, note it does still pass, or not pass, but it does still reflect across that y equals x line that runs along in here. Okay, so good to go. That's my graph, the inverse of that picture right here. Okay, now for the equation. Okay, so first of all, let's talk about what this equation is. All right, so hopefully we can identify, like I said, that this is a square root function, and we're going to think about what transformations were applied. Well, it's got that general shape, right? That 0, 0, the 1, comma 1, 4, comma 2. Okay, so there's no stretching, there's no flipping or anything like that. Okay, so my original function is only shifted. Okay, it's only a shift. We've got to think about what shift that would be. Well, this point, right, is originally here, so it's a 1, 2, 3 to the left shift. So that's going to be the square root. Okay, and since it's to the left, right, it's on that inside of the square root, and then it's reversed, so it's going to be the square root of x plus 3. Okay, and that is my equation for this graph, my original. Okay, now the question is, what is the inverse? Okay, so what is the inverse? Okay, and in order to find it, okay, what we're going to do is we're going to follow those steps that we talked about up here. Okay, so we're going to switch x and y, and then we're going to solve for y. So let's go ahead and do that. All right. Now, notice it talks about y. Okay, so what we could do, what I like to do here is I do like to actually change my f of x to y, just to make our lives a little bit easier. So, step 1. Okay, we're going to just rewrite it. Okay, this is my original. Okay, and then we're going to do step 1. Okay, so when we see step 1, that's what it's referring to, the switch x and y. So let's go ahead and do it. We've got x instead of y. Okay, so we switched it right there, and instead of x, y, and there we have it. Okay, now that's step 1. Step 2, usually a little more complicated. Okay, because now what we're trying to do is we're trying to unpeel the function, and we are trying to get y by itself. So that's my goal. We just want to get this alone. We want y alone, all by itself on one side. Okay, so in order to do that, okay, what we're going to have to do is we're going to have to get rid of that square root. Okay, well, in order to get rid of the square root, I'm going to square both sides. So that's where I'm going to go ahead and put this right here. Okay, and that is honestly kind of the bulk of it, because once we get rid of that square root, it's relatively simple from here. Okay, the only thing we need to do is just, in order to get y by itself, subtract 3 on both sides, so minus 3, minus 3. Okay, so we end up with x squared minus 3 equals y, and that's my inverse. Okay, that is my inverse. All right, now let's go ahead and think about the domain and range. Okay, let's just go ahead and find it for one of them, and if we can remember, what we learned, right? Once we find the domain and range for the original function, you just switch them for your inverse. Okay, so let's go ahead and talk about the domain and the range for that original square root of x plus 3. Okay, so the domain, all right, and I'm starting at negative 3. Okay, so it starts here. It does touch that point. Okay, so I've got a bracket, and it's going all the way to infinity. Okay, range. Lowest y value is at 0. Okay, my lowest y value is at 0. Okay, so 0, comma, infinity, and then goes up from there. Okay, so if I want to talk about the domain and range, literally we just switch them. So domain for the inverse is now, right here. Okay, so the range is now the domain, and then the vice versa. Okay, so down here for the range, I'm going to go ahead and write the previous domain. All right, cool. All right, so that's kind of talking about now we've seen an example of where we find